This is 5.3 part 2, factoring by grouping, and please make sure you write this whole thing down. This does not just go for today. Some of you guys are not writing down the titles on your notes, and you really need to, so please write that down. Write down everything. So what we're going to do today is the second part of our first lesson on factoring, and we're going to do something called factoring by grouping. And this happens when sometimes we might be able to factor more than just one term out of a polynomial. Sometimes we might be able to factor a binomial out, maybe even a trinomial, although today we're just going to stick with binomials, so things with two terms. So remember that to factor something means I'm dividing something out of a polynomial. I'm dividing it out of every single term instead of multiplying it into the polynomial. So if I look at this polynomial, I've got two terms here, and each of those terms, so here's one term, and here's another term. In each of those terms, there are two factors. A minus b times x plus 5 is the first one. The second one also has an a minus b and a x minus y squared. So what I'm going to do here is I'm going to be pulling this a minus b. Since it's in both of those, I can divide it out. So I'm kind of opposite of distributing. I'm going to pull it out and put it out in front. So I'm going to write a minus b in parentheses out in front because that's what I'm factoring out. And then what you do is you open up some parentheses to write what I'm left with. So what I'm left with is, well, in this first term here, the red one, I divided out a minus b, so those are now gone. So all I'm left with is this x plus 5. And then in my second term, I'm left with the x minus y squared. So I'm left with x minus y squared. Now, since it was a plus here, we want a plus in the middle of those, and I want everything behind what I factored out, and I factored out the a minus b, everything behind that should be in its own set of parentheses, so I actually had to put a bracket on this one. So just to recap here, this a minus b out in front came because I pulled it out of both of those, so it's out in front now. This x plus 5 right here came from, it was what's left in the first term, and then the x minus y squared is what's left in the second term. I had a plus between them because of that plus right there. You don't have to draw all these arrows. I'm just doing that to make it look a little nicer. So let me kind of rewrite here I'm doing it to help you see things. It's actually looking worse. So let's write out here, try to write it a little neater what I have left. So I have a minus b is what I factored out, and then I was left with an x plus 5 and an x minus y squared. So what we want to do is just simplify this as much as we can. So I know I can simplify the stuff in those brackets. Remember, if I have a plus and then parentheses, I can just take out the parentheses. So what I really have here is the a minus b out in front. And then in these brackets, which I can now change to parentheses because those are going to be the only grouping symbols left, is just x plus 5 plus x minus y squared. So I just took out the parentheses there. And now I just see one instance of like terms I can combine in those second set of parentheses. So I still have a minus b right here. In my second set, I can combine x plus x, and that's 2x. I'm adding up, so I change the coefficient, not the variable. 2x, and then I have just the plus 5 minus y squared. I can't combine those with anything. So this would be my answer. I have factored that polynomial in the beginning. I now am left with only factors. There are pluses and minuses, but everything is contained within its own factor. All right, let's try another one, and this one is truly factoring by grouping. So for this example, we are going to factor this polynomial, y to the 3 plus 3y squared plus 4y plus 12. So in this case, if I look at this polynomial with 4 terms, I don't see anything I can divide out of all 4 of those terms. Not every term has a coefficient that I could factor out. Not every term has a y. That last term, the 12, doesn't even have a y on it. So what we're going to do is we're going to think of this as being broken up into two pieces. So I'm going to think of the y to the 3 plus 3y squared separately than the 4y plus 12. So what I'm going to do is first let's just factor the part that I underlined in blue. So if I look at y cubed plus 3y squared, I can factor out a y squared from each of those. So then I'm going to write what I'm left with inside my parentheses. So y squared, I'm left with a y right here, because y to the 3, take out a y squared is just y. And then I'm left with a plus 3, because if I distributed this, I would want to end up with what we have here. Y squared times y is y to the 3, and y squared times 3 is 3y squared. Now in my second set of parentheses, from 4y and 12, the only thing I can factor out is a 4. So what I'm going to do after what I wrote in blue is I'm going to write plus 4 because I'm going to factor out a 4. In my parentheses, I have to write what I'm left with. So if I wanted to distribute this 4 and get this, I have to write what should be in here. So I need a y for my first term because 4 times y is 4y. And for my second term, I need a 3 because 4 times 3 will get me back to that 12. So now I have a polynomial with two terms. We've got this term and this term. Each of those terms has a common factor. Both of those terms have a y plus 3. So what I'm going to do is I'm going to pull the y plus 3 out and I'm going to factor it out. So I'm going to put a y plus 3 in front here, and then I'm going to write what I'm left with. So I am left with, my first term is just y squared, and my second term is just a positive 4, so plus 4. And that's it. I can't simplify anything, so my factored form is y plus 3 times y squared plus 4. We're trying to get it, remember, when we're factoring, everything needs to be separated by a separate set of parentheses. No pluses or minuses in between the parentheses. Alright, let's try another one. We're going to try this method again of factoring by grouping. Alright, get this one written down. So we're going to factor this polynomial. Again, there's nothing I can divide out of every single one of those terms. I don't see any number I can divide out of all of them. And there's no x on the minus 15, so I can't pull an x out of all of them. So we're going to have to factor this by grouping. Now, this is a good example because what you're going to see is that sometimes you need to rearrange your original polynomial before you can factor it. So what you want to do in general, this almost always works, is you want to write it in descending order when you're looking at the powers of x. So the highest power of x I have is 4x to the 3, so I'm going to rewrite it with that is going to stay first. Then I'm going to put the 20x squared. Then work our way down. We'll do the minus 3x. And then finally the minus 15. So all we did so far was rewrote this with descending powers of x. This almost always works to make factoring by grouping work, if you're trying to make that work. So what I can do here is look at this in two parts. We've got 4x cubed plus 20x squared, and then we'll look at the minus 3x minus 15 separately from that. So let's start with my first group that I'm looking at. It looks like from 4 and 20, I have a common factor of 4, so I can pull a 4 out. And then I also can pull x squared out of both of those. So remember, I'm kind of pulling this out and putting it out in front here. And then I'm going to write what I want to be in those parentheses so that if I distributed, I would get back to what I started with. So 4x squared, if I want to get 4x to the 3, I just need another x. And then if I want to get 4x squared to equal 20x squared, I just need to multiply it by 5, so plus 5. Now, when we factor something out of our second set, the negative 3x minus 15, remember that what we want to happen, I'm going to go back and look at our previous one, what we want to happen was, see how we have the same thing here and here? We want the same thing to be in both of our terms. So if I pulled out a positive number, like if I pulled out a positive 3 right here, I would be left with x minus 5. and that is not the same as that. So we don't want to pull out the positive 3 right there. What we want to do is if we pull out a negative 3 right there, let's see what we're left with in our parentheses. Let's see, negative 3 times what will get us negative 3x? Well, negative 3 times x will get us negative 3x. And then negative 3 times what will get us negative 15? Well, if we multiply by a positive 5, we'll get a negative 15. Now I have two terms, and both of those terms have the x plus 5 in them. So that's what I'm going to factor out to go in front of my polynomial now. I'm going to factor out an x plus 5. So let's write that out in front. And then I open up my parentheses to write what I'm left with. So I am left with a 4x squared and a minus 3 right there. And now we are done factoring. I don't see anything else I can pull out of either of those factors, so we know we are done. What I'd like for you guys to do is try one on your own. So I want you guys to try using the same method to factor this guy, and we'll go over this first thing tomorrow morning. I actually already put this in descending powers of a for you. So try factoring that guy using the same method. Alright, I've got one more I want to do with you. It's going to have like a little weird thing with a negative in here. So we're going to factor ax minus bx plus by minus ay. I don't see anything I can pull out of every single one of those terms. Not all of them have an a, not all of them have a b, not all of them have an x, and not all of them have a y. But if we split it into parts, I can find some things that they both have. So in this first group right here, ax minus bx, I can pull the x out of those, and I'm left with a minus b. Now in my second one, let's just look at something here. I'm going to end up erasing part of this, so you might want to wait to write it. I could pull a y out, right? I could pull out a positive y, and I'd be left with b minus a. Now, these are really close. The problem is they're opposites. The a is positive in one and negative in the other, and the b is negative in one and positive in the other. So if we wanted to change the second one to have the opposite sign on those, negative b and positive a, all we have to do is pull out the opposite sign, because if we divide by a negative, it'll change the sign of both of those things. So let's redo that. Instead of pulling out a positive y, let's divide each of those by a negative y, so that I am left with right here, if I divide by a negative y, well, I'm dividing a positive by a negative, so that's going to leave me with a negative b. And if I divide this term, negative ay, by a negative y, negative divided by negative is a positive, so I'm going to end up with a positive a. Now, as it stands right now, this does not look exactly the same as this, but remember, we could reorder the second one to look like a minus b. So what I've got here is x times a minus b minus y. I'm just going to reorder this, a minus b. So these are the same thing. I just reordered that second set of parentheses because now both those terms have an a minus b in it, and I can pull that out in front. So I'm going to pull my a minus b and factor it out of both those terms, and what I'm left with is x minus y. And we are done factoring that polynomial. Again, I have one I want you to try. Try doing the same process we just used for that one. So I want you to factor this polynomial, xc minus xd minus 2c plus 2d. Alright, come with those two done and we will go over them tomorrow. If you actually put effort into it and try them, I guarantee you will be doing better in this class.